myself, Paula Makona, Assistant Professor of EC Department at LJ Institute of Engineering and Technology. Welcome to the session of satellite communication. In the last session, we have started unit number 3, that is a geostationary orbit. Now, in today's session, we are going to cover how to calculate azimuth angle, what is latitude and longitude, and the basic introduction of antenna loop angle. Right? We have seen in the last session the definition of azimuth and elevation angle. Now, what is the importance of antenna loop angle? The loop angle for this ground station antenna, which are the azimuth and the elevation angle. What is the need of it? It is required to point that antenna directly at the satellite. That's why we need to understand the two angles that are azimuth and the elevation angle. And we have already seen that in general, no tracking should be necessary with the large earth station that is used for the commercial communication. Why? Because the antenna beamwidth is very narrow, right? So, the tracking mechanism which is required to compensate for the movement of satellite about the nominal geostationary position. So, with the type of antenna which are used for the home reception, our antenna beamwidth should be quite broad. And for that, no tracking is necessary. Why? The beamwidth is broad. That means the directivity is low. That means that signal is not going to be reached up to a longer distance. Alright? If we want to transmit a signal to the longer distance, we need to make beamwidth to a narrow, because the beamwidth is inversely proportional to the directivity. If beamwidth is high, directivity is low. And if beamwidth is less, that means narrow, directivity is high. Right? So this allows the antenna to be in the fixed position at which we can use a small antenna for the reception of satellite TV. Right? It can be fixed at the side of homes. Right? At which angle, at which azimuth and the elevation angle, we are getting a maximum signal. So we are going to fix our antenna at our home set. Right? The satellite is continuously moving. So we require these three pieces of information to determine the loop angle for the geostationary orbit. The first one is the Earth station latitude, which is denoted by lambda e. Second, Earth station longitude, which is denoted by phi e. And the last one, that is a longitude of the sub-satellite point, which is denoted by phi ss. Alright? This is also referred to as a satellite longitude. Sorry. So this latitude and longitude are the system of a geometric coordinate which is used in designating the location of the places on the surface of the earth. Alright. So for these three information, latitude, longitude, and altitude of the subsatellite point, which are going to be denoted by lambda e, phi e, and phi ss. In calculation of antenna loop angle, these three quantities are required, and it will be given in the example, in the exam. Alright. So, what do you mean by latitude and longitude? So these two quantities are the system parameter of geometric coordinate, where it is used and where it is used. We are going to designate the location of a place on the surface of the earth. So what this latitude gives the information? This latitude gives the information regarding to the location of the place, whether it is on north side or the south side. Alright, and what this longitude gives is the information. This longitude gives the information regarding to the position, whether it is the east side or the west side. Alright, based on the reference called the prime meridian. So, based on the position of my satellite, whether it is north side or the south side, we need to take its value either as a positive or negative. How? Latitude north will be taken as the positive angle and latitude south will be taken as the negative angle. Alright? Now about longitude. Longitude east of this Greenwich meridian will be taken as the positive angle, and for the west we are going to take it as a negative angle. So for example, if latitude is 40 degrees south, then we need to take it as a negative value. And if the longitude is given as the 35 degree west, as west is there, we need to take it as a value as a negative. For west, it is negative. Right? So we are going to place the minus sign before the number. If we are not going to denote the plus and minus sign, we are getting the wrong answer. Alright? So this must be considered before calculation of antenna look angle. So first we are going to start the calculation of azimuth angle. We require two types of triangle involved in the geometry of below figure. First one is spherical triangle, second one is the plane triangle. So considering the first over this diagram, this is our earth, this is north pole, this is south pole, and over here at a certain height my satellite is there. Okay, so if I am going to project vertically onto the surface of earth, I am getting this point. So this point is known as a sub-satellite point. Right? Now, from the earth station, at which distance my satellite is located? So it is going to be indicated by a small d. Alright? And what is AE? The AE is latitude of the earth station. What is R? R is the radius of earth. Alright? Now, what is lambda E? Lambda E is the latitude of the earth station. So over here we are going to divide this diagram into two parts. For the calculation of azimuth angle, we are going to consider the spherical triangle, and for the calculation of elevation angle, we are going to consider the plane triangle. Right? Now, considering the spherical triangle, this one. Sorry, this dark arc for small c, side small a and side small b, what it represents? So the side a is the angle between the radius to the north pole to the radius to the sub-satellite point. This is small a. Okay, this is a radius to the sub-satellite point to the radius to the north pole. Okay. Second, we are going to consider the small b, but from this diagram we are able to estimate the value of small a is in 90 degree. Right? Now small b, what is small b? The angle small b is the angle between the radius to the earth station and the radius to the sub-satellite point. Alright? Angle C is angle between the radius to the earth station and the radius to the north pole. These three angles are there. Alright? So total 6 angles are there. Small ABC and capital ABC. We have already noted the small ABC. Now the time is indication of capital ABC. We have a capital ABC are the angle between the planes. That is, plane A is angle between plane C and plane B, right? Now, capital B is the angle between plane C and plane A, and capital C is angle between plane A and plane B. Angle between plane A and B. Alright. So there are total 6 angles. Now we are going to calculate all these angles, and from this we are able to find out the azimuth angle. And this is the plane triangle that we are going to use for the calculation of the elevation angle. Now, capital B is equals to phi E minus phi SS. How it comes? It comes from over here. Capital B, this is capital B, phi E, that is the longitude of Earth station, and this is phi SS, that is the longitude of sub-satellite point. Small a that we have already considered, it is 90 degree. Small c, that is equal to 90 minus lambda e. How it comes? Total angle is 90 degree. And if I am going to subtract that lambda e, then we are able to calculate the value of small c. For capital A, it is sine inverse sine mod b upon sine small b. Alright? From over here. And this is for the plane triangle, in which this is the radius, this is small b, this is AGL, there is a radius of geostationary orbit, this is the distance between the Earth station and the satellite. Alright. Now, how to calculate the azimuth angle? From this 4 diagram, we are able to estimate the value of azimuth angle based on the location of my satellite and location of my Earth station. Alright. So, consider the diagram A, in which my Earth station is towards west side and it is towards south side. Alright. So for that, if it is a west side, the lambda e will be a less than 0. Why? Because the value is negative. Capital B will be a negative. Why? Because it is towards south. Alright. So both the values are negative. That's why we are going to calculate the azimuth angle as a capital A. Whatever the value of A will be the value of azimuth angle. Right? Now consider diagram B. As magnitude will be measured whether it is towards east or west. Right? So we can say that my Earth station is towards east. That's why that value will be greater than 0, and if its value is towards the south, then we will take it as a value is a negative, right? So lambda e will be less than 0 and capital B, that is longitude, it will be more than 0, right? So for that, the azimuth angle is 360 minus A, right? So B is for longitude, alright, and lambda is for E is for latitude, alright. Now case C. For lambda E, its value is greater than 0. Why? Because the sub-satellite point is towards east side, and for longitude, it is north side. Alright. So 180 minus. Similarly for the fourth case, both are positive. Okay. Greater than 0, greater than 0. So 180 plus whatever the value of capital A is going to be added with the 180. Right? So this is a way to calculate the azimuth angle. So you need to remember, rather than a score diagram, you need to remember this table. Okay. So over here, the calculation of azimuth angle is finished. I have referred this references, but still if you have any doubt for the calculation of azimuth angle, you can ask me anytime on my below email ID. Till then, thank you for your attention.